Well, so question number 1 for physics part test 3, I'm just repeating this quickly. So it says, told that there was one cube and a charge was placed at the midpoint of one of the side of the cube. Now, if you want to find out the amount of flux through one of the cube, then you need to first surround this cube symmetrically from all sides. So we need 3 more cubes to completely surround this charge cube from all sides. Then the net flux by the cube charge is q by epsilon naught. So the flux through each of the cube will be q by 4 epsilon. Is that clear? Ungli mat khao. Question number 1 done. Let's go for the next question. Question number 2. Question number 2 says a pendulum ball of mass m carrying a charge q is at rest with its string making an angle theta. So this is a ball and this is making an angle theta with the what? With the vertical in a uniform electric field. So you know the forces that are acting are mg and tension along this direction. But if the string is moving towards the right, there has to be a qe force which is acting along this direction. So this tension will have 2 components, t cos theta in the vertical direction because this angle is theta and this is t sin theta. Then of course t sin theta equal to qe and t cos theta is equal to mg. Now they want you to find out the tension in the string. So either you can use this formula which says t equal to qe by sin theta, or you can use this formula t is equal to mg by cos theta. So the options which are given, the correct option is qe by sin theta. So 2 option C is correct. Okay. Question number 3 में क्या बोला है? 3. This is actually a memory based question because here हम लोग क्लास में निकालने के जाएंगे तो एग्जाम के टाइम निकालने जाएंगे तो टाइम खत्म हो जाएगा. It says the number of electrons for 1 coulomb of charge. 1 coulomb of charge में कितना electrons होता है? So you need to remember this value. 6.25 into 10 to the power 18. ये आता कैसे है? 1 कूलम चार्ज डिवाइडेड बाय एक चार्ज की एक इलेक्ट्रॉन के ऊपर कितना चार्ज? That is 1.6 into 10 to the power -9. ठीक है? So if you do this, you are going to get near about 6.25 into 10 to the power 18. Clear? Next question is interesting. Question number 4. What is it saying? Question number 4 की बोल से let EA be the electric field due to 2 short dipoles in the due to a short dipole in the axial plane distant. Oh no, this is not interesting. This is a very simple question. They are saying for a dipole, say this is plus q, this is minus q. Say it's a dipole. At the axial position, the electric field is EA. At the equatorial position, the electric field is EQ. Electric field is EQ. Now they are saying what is the relation between their magnitude. So you know this is a formula that EA is always twice of EQ. E axial is always twice of E equatorial. Remember the formula? E axial का formula क्या होता है? It was 2p by r cube 1 by 4 pi epsilon naught और E equatorial का होता है p by r cube. P by r cube 1 by 4 pi epsilon naught. So this EA is exactly twice of EQ, right? So you can remember this. You cannot have time deriving these equations. Okay. Question number 4 is this. Question number 5. 5 will go to the point. This is interesting. थोड़ा ध्यान से सुनना है. It says the point charges capital Q and minus TQ are placed at some distance apart. If the electric field at the location of Q is E, the electric field at the location of minus 2Q will be. मतलब बोल रहे हैं कि ये एक Q है और यहाँ पर minus 2Q है. Now they are saying at this point where Q charge is placed, the electric field is E. अगर at this point electric field E है तो ये वाला point electric field कितना? Now this is a very simple question. All you need to understand is कि ये जो point में जब हम लोग electric field निकालेंगे ना, when the point where you find out the electric field, वहाँ पर जो charge होता है वो electric field पे contribute नहीं करता है. तो यहाँ पर जो इलेक्ट्रिक फील्ड हो रहा है वो किसके लिए हो रहा है? So you can say E is equal to minus 2Q by 4 pi epsilon naught into ये डिस्टेंस का r होगा आया ना. क्लियर? सो अगर ये वाला पॉइंट में इलेक्ट्रिक फील्ड ई डैश होगा, देन ई डैश विल बी q by 4 pi epsilon naught r. यस और नो? अब देखो e को हम लोग क्या बोल सकते हैं फिर माइनस ये q by 4 pi epsilon naught r is nothing but e dash. So this is minus 2 e dash. So therefore e dash का वैल्यू क्या होगा? e by minus, that is minus e by. So the answer will be minus e by 2, which is option C again. हाँ, ये वाला पॉइंट के लिए, पॉइंट का इलेक्ट्रिक फील्ड के लिए वो रिस्पॉन्सिबल है और वो वाला पॉइंट का इलेक्ट्रिक फील्ड के लिए ये रिस्पॉन्सिबल है. Is that clear? Yes sir. Question number 6. 6 में बोल रहा है two positive point charges of 12 and 8 microcoulombs respectively are placed 10 cm in air. The work done to bring them 4 cm closer. So you know work done is equal to negative of change in potential energy, और negative change in potential energy का formula है 1 by 4 pi epsilon naught q1 q2 into 1 by r2 minus 1 by r2. So you can put a minus sign in front of it. ठीक है? चेंज इन पोटेंशियल एनर्जी का ये फार्मूला है. सो हम लोग को जस्ट यहाँ पर वैल्यू पुट करना है और आंसर निकालना है. सो q1 and q2 are 12 microcoulombs each. So 12 into 10 to the power minus 6 into 8 into 10 to the power minus 6 into 9 into 9 into 10 to the power 9 1 by 4 by epsilon naught के लिए, और 1 by r2 minus 1 by r1 is 1 by r2. Then 4 centimeter closer. 4 centimeter closer means 6 centimeter. 0.06 minus 1 by 0.1. Okay, so if you simplify, it will come out to be 5.8 joules. This is option B. ठीक है? Next question, question number 7. It says that the electric potential V, which varies with x, is given by V equal to 5 plus 4x square. The force experienced by a negative charge of 2 microcoulombs, how much? So when you want to find out the force in an electric field, it is given by F equal to Q into E. But for that, you need E. So how do you find out E? E is equal to minus U dx. So if you differentiate this, it will give you minus 8x, right? X square को differentiate करने से 2x आएगा, 4 to the 8. So minus 8x. इलेक्ट्रिक फील्ड का वैल्यू मिलना है minus 8x. अब फोर्स कितना एक्सपीरियंस करेगा? F equal to Q into this minus 8x. So Q का वैल्यू है minus 2 into 10 to the power minus 6 into minus 8 into x है 0.5. तो ये हो जाएगा 8 into 10 to the power minus 6 न्यूटन, which is option B. 4 और 5 सब लोगों का हो गया है? 4 और 5 तो है नहीं?
निश्वास नहीं.
Question number 8 क्या बोला है? बोला है a cube of side B has a charge Q at each of its vertices. What is the electric potential at the center of the cube? So एक cube है जिसका 8 वर्टेक्स में 8 को चार्ज है और सेंटर में पोटेंशियल कितना है पूछा है. रिमेंबर पोटेंशियल इज अ स्केलर क्वांटिटी, वो वेक्टर क्वांटिटी नहीं है. बहुत जन इसको जीरो बता दिया. क्यों? इलेक्ट्रिक फील्ड निकालने बोले हैं क्या? क्या निकालना बोले हैं? पोटेंशियल निकालना बोले. तो सबके लिए पोटेंशियल कैलकुलेट करना पड़ेगा और एड अप करना पड़ेगा. बट सी द फनी थिंग इज सिंस द सेंटर इज सिमेट्रिकल टू ऑल द वर्टिसेस, किसी भी एक वर्टेक्स के लिए निकालो और उसको इंटू 8 कर दो. तो एक वर्टेक्स के लिए जो चार्ज है, इसका मतलब चार्ज क्या है? Q और साइड B है. साइड B है, चार्ज Q है. तो एक वर्टेक्स के लिए पोटेंशियल कितना होगा? V इक्वल टू Q by 4 pi epsilon naught into ये डिस्टेंस. अब ये मालूम है डिस्टेंस कितना होता है? ये वाला डिस्टेंस सेंटर से एक कॉर्नर तक डिस्टेंस कितना होता है? √3 by 2, √3a by 2. माने √3b/2, ठीक है। सो दिस विल बी 2q/4πε0 √3b। ये एक चार्ज के लिए हुआ। ऐसे कितना नोट चार्ज है हम लोगों के पास? How many charges are there? 8 charges. So we just multiply by 8. So b equals to 8 into 2q/4πε0 √3b. So we could cancel this. It will be 4q/πε0 √3b, and that is option A. 8 का option A. Clear? नाइन का क्वेश्चन इंटरेस्टिंग है। यहाँ पर बोल रहा है पार्टिकल ऑफ मास 2 ग्राम एंड चार्ज 1 माइक्रोकूलम इज हेल्ड एट अ डिस्टेंस 1 मीटर फ्रॉम अ फिक्स्ड चार्ज 1 मिलीकूलम। If the particle is released, it will be repelled, and the speed of the particle when it is at a distance of 10 meters from the fixed charge is. So initially, they are saying that the point charges. This is a particle of mass 2 gram and charge 2 microcoulomb is held at a distance of fixed charge 1 millicoulomb. So this is 1 millicoulomb say, and this is 1 meter, and over here there is a 1 microcoulomb charge which has got a mass of 2 gram, that is 0.002 kg. ठीक है। अब क्या कर रहे हैं? ये फिक्स्ड है, this charge is fixed, but this charge was held initially. So इसको छोड़ेंगे तो they will attract or repel? Repulsion होगा? Repulsion होगा या नहीं? सुन ही नहीं रही हो। दो चार्जेस है, इसमें से एक फिक्स्ड है, एक मूवेबल है, फ्री है। तो इनिशियली इसको यहाँ पर हम लोग पकड़ के रखे थे, अब यहाँ पर छोड़ देंगे तो ये यहाँ रहेगा या कहीं दूर जाने का कोशिश करेगा या नजदीक आने की कोशिश करेगा? Because repulsion हो रहा है ना, दूर जाने की कोशिश करेगा। So they are saying when it will reach 10 meter distance away, how much will be its velocity? So what will we use? करेंगे क्या हम लोग? Force is variable ना, তাহলে আমাকে ইন্টিগ্রেশন করে বার করতে হবে। তত ঝামেলা করবার কি দরকার? Conservation of energy principle লাগে তো total initial mechanical energy is equal to total final mechanical energy. So total initial mechanical energy কত? Total initial mechanical energy হচ্ছে only the potential energy because there was no charges in motion. But total final जो energy, the mechanical energy, that you have both potential energy as well as electrostatic potential energy plus the kinetic energy. So initial total energy is equal to final total energy. So initial total energy will be 1/4πε0 Q1 Q2 by R. Our final total energy is R1. Final total energy is 1/4πε0 Q1 Q2 by R2 plus half mv square, because it will have both potential energy as well as kinetic energy. Yes, sir. So this will be 9 into 10 to the power 9 into Q1 and Q2 is 1 millicoulomb. Milli is 10 to the power minus 3 into 10 to the power minus 6 by R1 is 1 meter, and 9 into 10 to the power 9 into 10 to the power minus 3 into 10 to the power minus 6 by R2. This distance, the new distance has become 10 meters. देखो new separation कितना दिया हुआ है? 10 meters. So this will be 10 plus half into 0.002 into v square. So to solve this equation for v square na v, and the v will come out to be 90 meter per second. V will come out to be 90 meter per second. Okay. So this is a typical question. Keep this concept in mind. Whenever they say that two charged particles are left alone and they are moving away and they ask you to find out the final velocity, then you can always apply the conservation of energy principle. Okay. अच्छा, related to this, I'll just give you another concept. मान लो ये और ये दोनों का ही मास हम लोगों को दिया हुआ है, m1 और m2. ठीक है, और कोई फिक्स नहीं है, दोनों ही फ्री है, तो ऐसे इनिशियली रख के फिर छोड़ देने से क्या होगा? दे विल both of them will repel each other, तो रिपल्शन के लिए क्या होगा? बैठे रहेंगे एक दूसरे के पास, start moving away, so both of them will have velocities, so then how do you find out the velocity of both the particles? ये तो सिर्फ एक ही इक्वेशन देगा तुमको, यहाँ पर सिर्फ v स्क्वायर है ना, तो वहां पर हाफ m1 v1 स्क्वायर प्लस हाफ m2 v2 स्क्वायर दोनों ही लेना पड़ेगा, तो v1 और v2 एक इक्वेशन से कैसे सॉल्व करेंगे? नहीं हो पाएगा, कंजर्वेशन ऑफ लीनियर मोमेंटम भी लगाना पड़ेगा। इनिशियल टोटल मोमेंटम वाज 0 because we were at rest, final total momentum will be also equal, so m1 v1 plus m2 v2 equal to 0 करके सेकंड वाला इक्वेशन मिलेगा, तो इसमें से v1 स्क्वायर प्लस v2 स्क्वायर और वहां पर v1 और v2 का रिलेशन मिलेगा, सॉल्व करके we have to solve for v1 and v2। is that clear? हाँ या ना? नेक्स्ट वाला सम, क्वेश्चन नंबर 10। क्वेश्चन नंबर 10 में क्या बोला है? देखो 10 में बोला है कैपेसिटर ऑफ कैपेसिटेंस 2 माइक्रोफैराड is charged to a potential of 200 volt after disconnecting from the battery, it is connected parallel with an uncharged capacitor, the common potential is 20 volt, now the capacitance of the second capacitor. This is a very easy question, so you know common potential is C1 V1 plus C2 V2 by C1 plus C2. This is a direct formula, we have learned this, charge sharing between capacitors. Whenever it is a sum on charge sharing between two capacitors, we can use the formula V equal to C1 V1 plus C2 V2 by C1 plus C2. कहाँ पर यूज करेंगे? ओनली चार्ज शेयरिंग केसेस, मतलब दो कैपेसिटर पहले से अलग अलग से चार्ज किया हुआ है, उसको ज्वाइन करने से उसका कॉमन पोटेंशियल कितना होगा। तो यहाँ पर एक कैपेसिटर चार्ज है, दूसरा कैपेसिटर चार्ज नहीं है, मतलब सेकंड वाला कैपेसिटर का पोटेंशियल 0 है, मतलब V2 0 लेना पड़ेगा। तो C1 V1 कितना है? C1 है 2 माइक्रोफैराड 10 to the power -6 into V1 है 200 by C1 plus C2 दोनों ही, अच्छा C2 पता नहीं है ना हम लोग को, C1 है 2 into 10 to the power -6 plus C2 और कॉमन पोटेंशियल 20 दिया हुआ है, तो सॉल्व करके हम लोग को क्या निकालना है? C2 का वैल्यू कितना है निकालना है, and it will come out to be 18 माइक्रोफैराड। सॉल्व करने से C2 will come out to be 18 माइक्रोफैराड। समझ आया? अच्छा, क्वेश्चन नंबर 11, we have done a general formula this question number 11. A wire of resistance 3 ohm has been stretched to twice its original length. Stretched to twice its original length. So stretched to twice करने से हम लोग क्या करते हैं? Remember 2n square, sorry 2n square नहीं, r dash equal to r into n square. Remember we did this. N is the amount of stretching. कतो time stretch करा है। So we have stretched how many times? Twice. So it will be r into 2 square. R कितना है? 3 ohm. 3 into 2 square is, so the new resistance will become 12. ठीक है? The new resistance will become 12. Question number 12. A cell supplies a current of 0.9 ampere through a 2 ohm resistor and a 0.3 ampere current from a 7 ohm resistor. What is the internal resistance of the cell? So this is a general formula. When a cell is sending current to an external resistance, it is IR plus R. E is equal to I into capital R plus small r. Capital R is the external resistance and small r is the internal resistance. So we need to figure out the small r. So we'll have two equations. First situation says 0.9 ampere through 2 ohm resistor. So E equal to 0.9 into 2 plus R. This is equation 1. And then it sends how much? 0.3 ampere current through a 7 ohm resistor. So to solve simultaneously, and R will come out to be 0.5. Option A. ठीक है? क्वेश्चंस जो है सारा क्वेश्चंस घर में जाके खुद से एक बार बनाने का कोशिश करना, क्योंकि क्लास में हम सिर्फ डिस्कस कर दे रहे हैं। जब घर में जाके खुद से बनाओगे तब डाउट रहेगा या प्रॉब्लम होगा, देन यू कैन अगेन रीलोड द रिकॉर्डिंग एंड सी वॉच आउट कि वहां पर मैंने क्या बोला था जो तुम तब नहीं समझे। इट इज वेरी इंपॉर्टेंट टू सॉल्व द डाउट्स, मतलब एग्जाम में जो सम्स खुद से नहीं बना है वो खुद से बनाना बहुत जरूरी है। If you don't solve the sums, you'll not get to learn the questions, learn the methods. Methods सीखने को नहीं मिलेगा। समझ में आया? Question number 12 हो गया है। 13 क्या बता रहा है? Question number 13 says we have a a voltmeter having a resistance of 1800 ohm is employed to measure the potential difference across 200 ohm resistor, which is connected to the terminals of a DC power supply having an EMF of 50 volt and internal resistance of 20 ohm. What is the percentage decrease in potential difference across the 200 ohm resistor as a result of connecting a voltmeter across it? So they are saying ये हम लोग के पास एक वोल्टमीटर है having a 1800 ohm employed to measure the potential difference across a 200 ohm resistor which is connected to a DC of terminal 50 volt, internal resistance 20 ohm. So say this is the cell of 50 volt and it has got an internal resistance of how much? 20 ohm, and then it is connected to a resistor of 200 ohm. This is the circuit given, okay? And we have provided with a voltmeter which has got a resistance of how much? वोल्टमीटर को ऑलवेज पैरेलल में कनेक्ट किया जाता है 1800 ohm दिया हुआ है। Now they are saying what is the percentage decrease in the potential difference across the 200 ohm resistor as a connecting the voltmeter। मतलब वोल्टमीटर कनेक्ट करने के लिए उसमें परसेंटेज डिक्रीज इन पोटेंशियल कितना हुआ है। पहले हम लोग 200 ओम के बीच में पोटेंशियल कितना था वो निकाल लेंगे। कैसे निकालेंगे? विदाउट केस 1, विदाउट द वोल्टमीटर। विदाउट द वोल्टमीटर मतलब सिर्फ ये सिचुएशन, सिर्फ ये नीचे वाला, राइट? तो उसमें क्या था? करंट जो संग्रह रहा था वो करंट कितना होगा? I will be E 50 by R plus R, that is 220, right? अब जैसे ही हम लोग इसमें कनेक्ट कर देंगे, अच्छा इसके अक्रॉस वो पोटेंशियल डिफरेंस कितना है? therefore V equal to I into capital R means I into 50 by 220 into capital R is 200. One 1000 by 20. ठीक है, ये V1 था। अब केस 2 with the voltmeter। अब with the voltmeter क्या होगा? जब ये कनेक्शन यहाँ पर कर देंगे हम लोग, तब voltmeter जो है this and this they will come in parallel। तो they will come in parallel, तो उन दोनों का पैरेलल इक्विवेलेंट पहले हम लोगों को निकाल लेना पड़ेगा। 1800 प्लस 1 by 200, तो क्या हो जाएगा? इट विल बी 1800 और ऊपर 1 प्लस 9, राइट? सो 10 by 1800 is 180। That means R will come out to be 180 ohm. Now this R will be substituted in place of this. So now the current I dash, now the current in the circuit will be 50 by 180 plus 20। क्यों? क्योंकि ये पूरा का इक्विवेलेंट 180 है और ये 20 बाहर बैठा हुआ है, ठीक है? So this will be 50 by 200। Therefore V2 will be I dash into अभी वाला, so that is 50 by 200 into अभी वाला कितना है? 1, okay? 45 और पहले कितना आ रहा था? ये का कैलकुलेट कर सकते हैं। 1000 by 22 is how much? 40 45.45 45.45 तो देखो परसेंटेज चेंज कितना हुआ, देखो परसेंटेज चेंज इज इक्वल टू 45.45 minus 45, that is 0.45 by 45.45 into 100. So that is nearly equal to 1%. Okay, percentage changes 0.45 by 45.45 into 100. Okay, next question is question number 14. It says the deflection in a moving coil galvanometer falls from 50 to 10 divisions when a current shunt of 12 ohm is connected across it. The resistance of the galvanometer is B. So you know the formula I equal to Ig into क्या होता है? G plus S by S ना? I equal to Ig into G plus S by S. बस यहाँ पर डाल दो भाई. हम लोगों को क्या निकालना है? The resistance of the galvanometer coil G निकालना है. I कितना है? वो deflection of the moving coil galvanometer falls from 50 to 10 divisions, right? So पहले था 50, अभी 10 divisions हो गया. मतलब galvanometer 10 division रीड कर रहा है और G निकालना है, शंट है जो वो 12 होगा. So G is equal to what? 48 ohms, right? Question 15 says a galvanometer of resistance 10 ohm gives full scale deflection when 1 milliampere current passes through it. The resistance required to convert it into a voltmeter up to reading up to 2.5 volt is. Remember we did this. Whenever you need to convert anything into a voltmeter, what remains constant? The working current should remain constant. Working current constant होना चाहिए. तो पहले देखो यहाँ पर working current दे रहा है 1 millimeter, right? So working current equal to 1 milliampere. अब potential difference read कितना करना है? Working potential of voltmeter is equal to 2.5 volt. Therefore, now let the resistance of voltmeter be R. Then this is working current, this is working potential. So how do you find out the R, resistance of the voltmeter? V equal to IR. So R equal to V by I. So V is 2.5, I is milliampere, 10 to the power minus 3. So that is 2500 ohms, right? But the galvanometer has got a resistance of how much? Only 10 ohm, right? So कितना ohm series में डालना पड़ेगा? But galvanometer resistance is equal to 10 ohm. So therefore, the resistance to be connected in series. क्यों सीरीज बोल रहे हैं याद है ना? कोई भी वोल्टमीटर से गैल्वेनोमीटर से वोल्टमीटर बनाना होता है तो हम लोग क्या करते हैं, गैल्वेनोमीटर के साथ एक सीरीज में हाई रेजिस्टेंस डाल देते हैं ना, ये बन जाता है हम लोग का क्या, वोल्टमीटर. सो वो रेजिस्टेंस कैसे निकालेंगे? वोल्टमीटर का रेजिस्टेंस माइनस गैल्वेनोमीटर का रेजिस्टेंस. सो वोल्टमीटर का रेजिस्टेंस कितना निकाले हुए आप लोग? 2500 minus 10. So that is 2490 ohm. So this is the amount of resistance that has to be connected in series. 2490 ohms. Will you answer? Okay. Now the next question is question number 16. It says that a figure shows two capacitors. The figure is given in the next page. So this is the scenario. We have one capacitor and the other capacitor is connected with a switch. Initially the switch was closed and the capacitors C1 and C2 are 2 microfarad each. 2 microfarad, this is C1 and C2 is also 2 microfarad, and this potential difference of the cell is 5 volt. Okay, so initially potential difference across both capacitors were how much? You answered why? They are in what connection?
Sorry. Parallel बोलने जा रहे हैं.
In parallel connection, what remains same? The potential difference between the plates remains same. So, the first capacitor is 5 volt, second capacitor is 5 volt. So, of course, they'll store the same amount of charge because they are on the same capacitance. So, therefore, charge on each of them is Q equal to C into V, that is 2 into 10 to the power minus 6 into 5, that is 10 to the power minus 5 coulomb. Right? Now, what is happening? Now, the key is closed. Key is, open. So, key closed. Now, the key is open. Okay? So, if the key is open, then C1 remains connected to 5 volt battery. Well, so C1 remains connected to the 5 volt battery. तो मतलब क्या? उसके different, उसके across potential difference will remain same. But C2 is disconnected. Okay? Now a dielectric constant कितना constant बोला है? 5 is introduced. दिव्यांग है into both. So a dielectric is now introduced into both of them. So when you introduce a dielectric, what happens? The capacitance changes. Okay. So therefore, for C1, the capacitance is C1 dash equal to 5 into 2, that is 10 microfarad. Right? But what is C1? C1 remains connected to 5 volt. So उसके across potential difference will not change. It will remain the same because it is connected to the 5 volt battery. But what will change? The charge on it will change. Okay. So C1, since C1 is connected to 5 volt, therefore potential difference across it will remain same, but charge will become Q equal to CV. So C1 dash into V. So C1 dash is how much? 10 microfarad into V is 5. So this will become 15 microfarad. will change to 15 microcoulomb. ठीक है? हाँ? 50 microcoulomb. Sorry. I was thinking something different. 50 microcoulomb और initially कितना था? Initially था 10 microcoulomb. ठीक है? Initially था 10 microcoulomb, लेकिन अभी कितना हो गया? This is for C1. But what happens for C2? For C2, new capacitance is C2 dash equal to also 10 microfarad. Since C2 is disconnected from battery, therefore charge remains same. Therefore the charge will remain same. But new potential difference V will be equal to Q by C2 dash. So Q पहले कितना था 10 microcoulomb, 10 into 10 to the power minus 6 by C2 dash is how much? 10 microfarad, 10 to the power minus 6. That is 1 volt. So the new potential difference across C2 will be 1 volt. Is that clear? So this sum was just given to clear up a very important concept that whenever a capacitor remains connected to a circuit, इसका potential difference change नहीं होता है, and whenever a capacitor is disconnected from a circuit, इसका charge change नहीं होता है, और उसके हिसाब से लोग करते हैं. Is that clear?
जल्दी से बना लो.
Question number 17. It says two parallel plate capacitors X and Y have the same area of plates and same separation between them. That means identical capacitors. बोल देने से हो जाता है. X has air between the plates while Y has a dielectric constant of 4. They are connected in a series to a cell of EMF 15 volt. Calculate the capacitance of each capacitor if the equivalent capacitance of the combination is 4 microfarad. Now they are saying there are two capacitors which are connected in series to a cell. One is having some dielectric. Both are identical capacitors. So initially say इसका C है, dielectric constant अगर K है, तो इसका कितना होगा? Kc. So in series connection, you know the equivalent capacitance is given by 1 by C equal to 1 by C1 plus CS. So 1 by CS will be equal to 1 by C plus 1 by Kc, right? So if we simplify, so CS equal to Kc by K plus 1 आना चाहिए, right? यहाँ पर equivalent capacitance 4 microfarad दिया हुआ है, मतलब this is 4 microfarad it is given, और C का वैल्यू निकालने बोलेंगे. K का वैल्यू कितना दिया हुआ है? 4. So 4C by 4 plus 1 that is 5. So 20 microfarad equal to 4C, मतलब C equal to 5 microfarad. ठीक है? So the capacitance are 5 microfarad each. एक capacitor का capacitance 5 microfarad. This is the first part. Second part क्या बोल रहे हैं? बोल रहे हैं कि calculate the potential difference between the plates of X and Y. तो obviously मान लो ये X है हम लोग का और ये Y है. Y contains dielectric, right? ये X है और ये Y है. So PD across is the second part. PD across X. कैसे निकालेंगे? How do you find out potential difference? V equal to, जल्दी बताओ, Q by C, right? लेकिन Q कहाँ से पता चल जाएगा हम लोगों को? Q कैसे पता लगाएंगे? तो मतलब पहले Q पता लगाना. You know in series connection जब charge is same on both the capacitors, पता है? In series connection charge is same. So पहले let the charge on each capacitor be Q. Therefore, Q should be equal to the equivalent capacitance, that is CS into V. CS कितना था हम लोग का? 4 microfarad दिया हुआ है ना? 4 into 10 to the power minus 6 और V कितना है? सेल का पोटेंशियल डिफरेंस कितना है? 15 volt. So 15. बोलना चाहिए short. 60 microcoulomb. Right? This is the charge. Therefore, PD across across x is equal to q by c, that is 60 into 10 to the power minus 6 by x का कैपेसिटेंस कितना है
5
right 5 microfarad, so it will be 5 into 10 to the power minus 6, that is 12 volt, or dV across y will be 16 into 10 to the power minus 6 by, इसमें डायरेक्ट कांस्टेंट 4 है ना, तो it will be 5 4s are 20 microcoulomb, 20 into 10 to the power minus 6, so that will be 3 volt. समझ आ रहा है? हाँ या ना? अब क्या करेंगे? x क्या है बता? Therefore, ratio of electrostatic energy, ये पार्ट C है ना? C. Ratio of electrostatic energy is half C1 V1 square by half C2 V2 square. So half of cancels, C1 V1 square, C1 कितना है? First वाला 5 microfarad है ना? 5 into 10 to the power minus 6 into V1 square is 12 square, और दूसरा वाला 5 into 10 to the power 20 into 10 to the power minus 6 into 3 square. Próximo. Pura, pura. 4:1. 4:1 आएगा. ठीक है? Realize? Question number 18 is the derivation. अच्छा, vector form of Ohm's law is vector form of Ohm's law. We have derived this in the class. Go for the recordings. The final form is J equal to sigma into E. This is what you need to break. J equal to sigma into E. Okay. Or you can also prove E equal to rho into J. That is also. हाँ, तो वो एक ही बात है. हाँ, सिग्मा इक्वल टू 1 by rho होता है, तो ऑब्वियसली सेम होगा, राइट? अब नेक्स्ट क्या है क्वेश्चन नंबर 19. 19 में क्या बोला है? 19 में बोला है कि a resistance wire is stretched 4 times 4% in length. Find the percentage change in its resistance and resistivity. तो यहाँ पर देखो 4% चेंज बोला है ना, सो यहाँ पर हम लोग नॉर्मल परसेंटेज कैलकुलेट नहीं करके हम लोग एरर्स वाला कंसेप्ट से अप्लाई कर सकते हैं. ठीक है, तो क्या बोलेंगे हम लोग बोलेंगे R होता है रो L by A ना, सो dr by R will be equal to dl by L plus dA by A. ठीक है, रो को क्यों नहीं लिए? क्योंकि रो इज कांस्टेंट, वो चेंज नहीं करता है. और जब भी स्ट्रेचिंग का कंसेप्ट आता है तब वॉल्यूम कांस्टेंट होता है. V equal to L into A कांस्टेंट होता है. So del V by B equal to del L by L plus del A by A. अब del V by B कितना है? 0. वॉल्यूम चेंज नहीं लेते हम लोग. स्ट्रेचिंग के टाइम नो वॉल्यूम चेंज. So इसीलिए del L by L कितना परसेंट दिया हुआ है? 4% ना. तो यहाँ पर 4 by 100 मतलब 4% ही डाल दो बस, और कुछ नहीं. 4% प्लस del A by A. So del A by A क्या हो जाएगा? -4%. अच्छा, एक छोटा सा गलती हो गया यहाँ पर, माइनस होगा क्योंकि ये डिनोमिनेटर में है ना, जैसे तो -4% del A by A. अब del L by A कितना था? 4% था, माइनस ऑफ -4%, so total 8%. dr by R, the resistance will increase by 10%, 8%. The resistance will increase by 8%. बोले आज की पढ़ा लो. Question number 20 says that the current in a wire varies with time according to the equation I equal to 4 plus 2t. Yes, where I is in ampere and t is in seconds. Calculate the quantity of charge which has passed through the cross section of the wire during t equal to 2 seconds to t equal to 6 seconds. तो चार्ज कितना क्रॉस किया ना, सो I का y डेफिनेशन क्या है, dq dt 4 plus 2t होगा. So dq equal to 4 plus 2t into दोनों साइड हम लोग इंटीग्रेट करेंगे 0 to q और ये 2 to 6 seconds. So 4 integration of dt plus 2 integration of t dt. दोनों ही 2 to 6 seconds. dt का इंटीग्रेशन t होगा तो 4t from 2 to 6 plus 2 into t square by 2 from 2 to 6. तो ये क्या हो जाएगा 4 into 6 minus 2 प्लस इधर 2 को कैंसिल हो जाएगा 6 square minus 2 square. coulombs. Question number 21. It says two bulbs are working in parallel order. So in parallel, what is same for both the bulbs? The voltage is same, and the bulb A is brighter than the bulb B. Brighter means more power. Okay? Power of A is greater than power of, and power is what? B square by R. So B square by RA is greater than B square by RB. That implies RB is greater than. Okay? So which one is higher resistance? RB is of higher resistance. RB is of higher resistance. Okay? 4 lines, 2 marks. So you have to be very wise when selecting questions to answer. हाँ बस सेंटेंस में लिखने से नहीं चलेगा, कोई दिक्कत नहीं. जब तक तुम्हारा सही है, कंसेप्ट सही है, तब तक चलेगा, कोई दिक्कत नहीं. नेक्स्ट क्वेश्चन इज क्वेश्चन नंबर 22. इट्स अ सम बेस्ड ऑन Kirchhoff's लॉ. बहुत जनों ने इक्वेशन सही बनाया लेकिन इक्वेशन सॉल्विंग में मिस्टेक कर दी. मिस्टेक का कोई गुंजाइश नहीं रहना चाहिए. मिस्टेक मतलब क्या? एक मिस्टेक मतलब क्या? इतना कुछ सीखने का कोई मीनिंग नहीं बचा. हाँ, so this is a circuit and it's given already provided that the I3 is the current in the middle arm and I1 is in the left arm and I2 is in the right arm. ठीक है? So obviously ये वाला पॉइंट के लिए मतलब S के लिए जंक्शन लगाएंगे for junction S I1 plus I2 is equal to I3. This is equation 1. And for loop PQSP में जाएंगे. If I1 is the current over here, it will remain I1 over here, and I2 is the current over here, it will remain I2 over here. ठीक है? So P से start करेंगे. There is a potential drop -4 I1, then Q से S तक -10 I3, then यहाँ से यहाँ तक -1 I1, and then +4 equal to 0. This is equation 2. And for loop QRSQ, इसमें potential rise 3I2 -3.5 plus 2I2 and then plus 10I2 equal to 0. This is equation 3. Now we solve for them. and I1, I2, I3. I1 comes out to be correct answer 0.2. I1 is 0.2, I2 is 0.1 and I3 is 0.3. Solve them, you'll get these answers. Yes, sir? Next question is question number 23. It says a heater is rated. You know what is meant by rating? Power rating of any electrical device. Power rating of any electrical device gives you the resistance. If our heater is rated as 2.5 kilowatt 250 volt, इसका मतलब यह है कि P equal to V square by R. यहाँ से हम लोग रेजिस्टेंस निकाल सकते हैं. P is how much? 2.5 kilowatt means 2500. Voltage is 250 into 250 by R. So R comes out to be by 2500. 00 cuts 25. So 25 ohm. Alright. Now they are saying that if this heater is connected to a 200 volt source, what will be the current drawn from? So current निकालने बोले हैं, resistance मालूम है और potential difference कितना दिया हुआ है अभी 200 volt. So therefore I is equal to V by R. 200 by 25. 8 ampere. Is that clear? जब करंट निकालेंगे तब उस जो करंट का पोटेंशियल जो वर्किंग पोटेंशियल है उसमें डालना पड़ेगा, तभी निकलेगा, अदरवाइज नहीं निकलेगा. ठीक है. So question number 24 is also an easy question. 24 says, what is the safe largest voltage that can be put across a 98 ohm with 0.5 watt resistor? So 98 ohm 0.5 watt is the power rating. So obviously P equal to V square by R, right? So V square is equal to P into R. So V equal to under root of P into R. Under root of 98 into 0.5, which is 7 volt. So 7 volt is the maximum potential difference we can apply across the circuit. Right? Now look at question number 24. Many of you have written it correct answer but not proper representation. This is a very big problem with theoretical answers in physics. Question number 25 says, which conservation principle are involved in Kirchhoff's law? So obviously you know it is charge conservation and energy conservation, but which principle follows which conservation, that has to be clearly mentioned, otherwise you will not get the full marks. So for junction law obeys charge conservation and loop law obeys energy conservation. So you have to write these two statements clearly, bas full marks. अगर तुम लोग सिर्फ लिख देते हो चार्ज कंजर्वेशन और एनर्जी कंजर्वेशन तो मार्क्स नहीं मिलेगा. Is that clear? नीचे वाला हो गया सब लोगों का दोनों. Question number 20. Question number 26 says, in an experiment to measure the internal resistance of a cell by potentiometer, it is found that the balance point is at a length of 2 meters when the cell is shunted by a 5 ohm resistance and its length of 3 meters when the cell is shunted by 10 ohm resistance. So find the internal resistance of the cell. ठीक है? चलिए shunting values change करें, length को change करें. So when it is shunted, you know that the potential difference which is measured is V, not the E. EMF E measure नहीं किया जाता है, V measure किया जाता है. So V का expression क्या है? V is equal to I into क्या है? Capital R plus small r. अच्छा हमारे general formula खींच लो. What was the general formula? L1 by L2 capital R L1 by L2 equal to ठीक लगा L2 reduces, right? Second time L2 का reduce कर जाए, right? अच्छा. So see what is happening over here. This is the general formula. अगर हम लोग ऐसा करते हैं कि इसका जो ओरिजिनल रेजिस्टेंस है right. So in the second case, say this is R1, this is R1, and in the second case, it will be L1 by L3 equal to R2 plus R by R2. So original length of balancing will remain the same, but first case में R1 के लिए L2 length होगा और second case में R2 के लिए L3 length. So if you now make a ratio on both sides, दोनों का अगर ratio निकालेंगे, so what will you get? L1 will get cancelled, so you'll get L3 by L2 is equal to R1 plus R by R2 plus R और ऊपर में R2 और यहाँ पर R1, ठीक है? So it will be 3 by 2 is equal to 5 plus R by 5 into 10 plus R. Yes. So if you solve this, get the value of RS from the first. 30 plus 3R equal to 20 plus 4R. So R is equal to 10 ohms. Clear? The last question, question number 27. क्या बोला है 27 में? बोले हैं the adjoining figure shows a balanced Wheatstone bridge. Calculate the value of R. So balanced Wheatstone bridge में you know the arms are got the same ratio of resistances. तो यहाँ पर सिर्फ क्या करना पड़ेगा कि राइट हैंड साइड में जो 1100 के साथ पैरेलल में R कनेक्ट किया हुआ है इसका इक्विवेलेंट हम लोगों को निकालना है 40 ohm. This is the galvanometer and the connections are done from here. So इन दोनों का इक्विवेलेंट कितना होगा 100R by 100 plus R मालूम है ना इन दोनों का इक्विवेलेंट. Now we know P by Q is equal to R by S. So 100 by 200 is equal to this by 40, right? So 1 by 2 is equal to 100R by 40 into 100 plus R. So 200 plus R equal to 10R. So 200 equal to 8R. So R is equal to 25.